so maybe a little bit more on just, maybe some goals of that type of parallel part 2 problem, right? Where the setup is where this is your head loss of the pump. Here's your head of like part A. Okay, so with that in mind, in terms of cost savings, right, kind of if you were to get the problem set up right, you need all of these to lower at the same rate, right? So all these need to be equal, and they all need to be lower for lower cost, right, for lower energy costs. So how can you achieve that? Well, investigate then properties of ways to achieve that. So remodeling, right, when you remodel these things, it can lower that friction value, which does not really help at all. But you can look into that. You can see what actual cost savings you get from making, from choosing a new material. Maybe even do a buyback calculation. Right. And again, right, I kind of gave you these ranges of flow rates for these, right? Ranges of flow rates of like where they can and cannot be. Question is, can they even achieve these ranges? Something to ask yourself, right? Someone could just give you these dimensions, and someone could just say, I want this many gallons, etc. per minute, and then give you these dimensions and say, well, what pump do I need to buy? But I'm not putting out, right, the idea that is like someone could give you that question right in a contract, and they wouldn't know this idea that the head losses have to be equal. So if you have to add in pumps here to actually achieve some of these things, well, then you got to go ahead and figure out how to do that. If you find somehow there's an impossibility that this can't be satisfied based on these. So I hope so. I don't want maybe don't assume that's going to be the case, right? I'm not trying to trick you. I'm just trying to have you consider options, and it's an Excel sheet. So, right, in reality, you can just kind of see how these head losses based on each of these change by changing values. And it takes minutes of your time if you have it set up to calculate head losses. But you got to be checking this, right? And you can refer back to that parallel pipe problem setup that I had neatly printed ones, and then you have these sub-problem things. But you could go ahead, you could actually look into redesigning diameter sizes as well. Right? Go ahead and try to do resize. Maybe the pipes up higher need to be smaller or lower than the pipes below. You can go ahead and do that on your Excel sheet. As long as this is somehow achieved, you're obeying the rules, right? In fact, a pump in each one of these could work too, right? You just may need to look at like the energies of that. So you have a pump to a pump to a pump, but there's weird things happening right there. So maybe not. Maybe you shouldn't worry about that. Make it one pump. But this is a strange problem, I believe, and I put it there because sometimes you will get crazy requirements from people that have no idea about internal flows or pipe system problems. They just go, here are my pipe dimensions, here are the data I have, and tell me what I need to do. And then us as engineers, we have to kind of go in and say like, well, that doesn't actually even work. You have to do this, et cetera, et cetera. So again, I'm just kind of throwing maybe not red herrings. I'm just throwing like things that could happen in a problem like this that maybe I will see more questions pop up on the Slack about, or people have it totally right. But if you think you have it right, I would encourage you to check that. I'm going to check that when I get your projects. If it's not true, then congratulations, you've created free energy. But you did.